So we're ready to start talking about part 2 of our discussion of completion stage methods from the Completable Futures framework as applied in the context of the ImageStreamGang case study. And now we're going to talk about the apply filters async method. And this method is going to asynchronously filter and store images that have been downloaded after they complete downloading asynchronously. And after they're filtered and stored, they will then be stored, well, actually, after they're filtered, they'll be stored in the local file system on whatever device we're using. In one case, it could be like a laptop, so it would be stored on your local computing device on your laptop. If it was an Android phone, then it would be your Android phone device, and so on and so forth. We're going to use flat map here for reasons we talked about before, because we're going to have n filters that get applied to each image. So if we have 100 images, we'll get 300 filtered images if we have 3 filters to apply, and so on and so forth. So we use flat map to kind of keep this from being a very stream of streams kind of problem. Apply filters async, of course, asynchronously filters images and stores them into local files. And once again, later operations just ignore empty optional images, and we'll see how those get dealt with down here in this use of flat map, which will come later. So again, just to recap, flat map flattens everything. Think of the steamroller coming along. Remember, we talked about flat map in the context of parallel streams, and I mentioned how it's a problem with parallel streams because of the semantics of flat map are always sequential. It doesn't matter here because we're using a sequential stream anyway. We're not getting our parallelism from the parallel stream. We're getting our parallelism from the Completable Futures framework. So flat map works perfectly well in this context. What we get back is a stream of completable futures to optional images, which will have a value. The optionals will have a value if the image is being filtered and or stored, but will be empty if the URL had already been cached earlier. So again, we're just percolating this stuff down the chain. Here's apply filters async. This shows off some interesting little techniques. So as you can see here, we're going to asynchronously filter images and store them into files. We start by getting the list of filters to apply. And in your assignment number 3, we call them transforms to avoid confusion with the word filter, which has another meaning in streams. But when I did these slides, I didn't think that was an issue. So we say mfilters.stream. Let's say we have 3 filters. So we get a stream of 3 filter objects. And then we apply the map operation here. And what that does is it says for each filter, when the completable future to the optional image that's being downloaded completes. In other words, after we finish downloading the image that was coming down, then go ahead and apply asynchronously some action here. So this is the action that gets registered to be run asynchronously. So the completion stage method then apply async, registers this action, which again, of course, as always, is not executed immediately, but will be stored and run in a worker thread in the common fork join pool only after the image future completes downloading, which is exactly what you want. So notice how cleanly completable futures combine with sequential streams. It's really beautiful. Here's the actual action that we care about. If we have a non-empty image, in other words, we've downloaded the image, it's been downloaded, it's finished downloading asynchronously, then we can use the map call to do some processing. Keep in mind, if there's no image that was downloaded because there was no URL that wasn't already cached, there's nothing that's done by map. Here's the actual action that's registered with map. If the image is non-empty, then we're going to asynchronously filter the image and store it in an output file. And that's what this little factor method does. Make filter decorator with image. We pass in the filter in the image and we run this thing, and that will go ahead and apply the filter and store it in the file. That's actually very cool in its own right. It's basically an application of the gang of 4 decorator pattern, but we're focusing on concurrency here, not decorator patterns. So if you're curious, you can look at the code. It's really cool, but don't worry about that right now. So we're basically going to filter and store the image. And this is all going to get run in the context of a thread, a worker thread in the common fork join pool, which we get from the getExecutor factory method, which is part of our little framework. And then apply async is going to use that pool to run the computation. This will also, of course, then apply async will also return a new completable future that will trigger after the image has been filtered and stored. So after filtering and storing is done, then that completable future will be triggered. Now notice what's going on here. This is really funky. Apply filters async returns a stream of completable futures to optional images. And that is because map is going to return a stream. Notice there's no terminal operation here. Map returns a stream, and then apply async returns a completable future to an optional image. So therefore, map will return a stream of completable futures to optional images. And because apply filters async is called by flat map, that will then flatten that stream of streams into a single stream. And again, there's no terminal operation here. So a stream is returned, and we rely on flat map to flatten that stream. So you can see here, once again, flat map takes the stream of streams that comes back from apply filters async and flattens it into a stream of completable futures to optional images. Pretty mind-boggling. This is when it really pays to have the feature in IntelliJ or Android Studio that tells you what types are being returned from these intermediate operations in a stream, because otherwise your brain starts to melt down after a while. But we're not done yet. This stream, which at this point has quite a bit of completable futures to all kinds of asynchronous things that are off, not even running yet, about to start running. Collect is what's going to set all the wheels in motion, and we'll talk about what collect does in the next part of the lesson. So that's the end of the second discussion of applying completion stage methods, where we talk about the apply filters async method. Part 1 of this lesson series talked about the download image async. Part 2 talks about applying the filters asynchronously.